So Assalamu alaikum everyone. So in this session we are going to learn about databases. Okay, so today I won't be able to see the other screen, so if I am asking you something, just have somebody call it out that if you are understanding or not. So if you have any problem with the screen, just call it out. Okay. So why is this database required? The first thing is I would like to address this question later. Let me first talk about what is the meaning of data. Okay. So what is basically data? So data, we can tell it refers to any information or a fact or a statistics collected or observed or something measured. So basically whatever is, you can say, I'll write a short definition so that you also make notes. So I hope that you have copies with you so that you make notes with me. So it is any sort of information that is recorded. That is recorded. Okay. So it can be observed by something. For example, if we observe some data, if we observe weather, and if we keep the track of weather, so we are sort of making a weather data. So then we can measure it. For example, if you are measuring some temperature or the room temperature or some other temperature daily, so we can measure the data, or sometimes we can observe some things and you can collect them. Okay, you can observe height of the people and you'll measure. After observation, you'll do the measurement. So anything that we observe or measure, whether it be a statistical data or it be some other sort of information, so that is referred as data. So is the concept data clear? Anything that is recorded, basically what can be recorded somewhere, so it is data. So let's suppose right now we are capturing the video and we are capturing the audio, it is data. Okay, so this is data. So broadly categorizing, data can be qualitative and quantitative. Okay, so data can be qualitative and other one is quantitative. So what is qualitative data and what is quantitative data? So if you look, for example, if you have some quantity, let's suppose we'll say we have 50 people in this room or 50 people in this meeting. So here I am giving a quantity. Okay, so I am giving quantity to the people, so there are numbers or things like involved in that. And sometimes we just give description. So if something is descriptive, okay, that's we call it a qualitative data. So if something is descriptive and numbers are not involved, so there we call that data is qualitative. So for example, we have I will say we collected the data of 50 people. 50 in that is called quantitative, because we are quantifying it. By quantifying, I mean I'm giving a numerical number to you. By quality, I mean, for example, he is doing a really good job. So good, I am not giving any sort of quantity to it. Is this clear? Is the qualitative and quantitative clear? By quality, I do not basically quantify it. Quantifying means I do not give a precise number for it. But for the qualitative data, I give a precise number. So this is one type of data. So this is one categorization of data. So I can have qualitative and or I can have quantitative data. Okay. So the other type of data we can have structured and unstructured. We can have structured or we can have unstructured data. Unstructured data. Okay, so what's the meaning of structured data? If we have something organized, so if we have something that is pretty much organized, for let's speak, for example, if we are collecting your data, so you have filled a lot of forms. So in those forms we have your data that's organized pretty much like in a well format. So here we have your names, then we have your phone numbers, then we have your address, then we have your degree. So everything is stored in an organized fashion. Okay, so this data is called structured data. So where there is an organization, where there is some structure, we call it a structured data. And then we have something called as unstructured data. So unstructured data can be, for example, if I write something like this, Omar, then I'll write for example 50, then I'll write 6802, and I'll write 15 degrees centigrade. So there is no structure, but this is data, there is some meaning to it. Maybe I mean that the Umar weighs 50 kgs and his roll number is 6802, and when he came here temperature was 15 degrees centigrade. So but you are not seeing any sort of structure in this data. If you see over here, so there is no structure to this data, but maybe it contains some information. So we have to deal with this type of data as well, and we have to deal with this structured data as well. So the first thing is we read about, we can have qualitative data where we just give some description, then we can quantify the data to give it qualitative analysis. Then we can have other type of data, that's structured data. and we can have unstructured data. Is this much clear? Is it clear? I'm not seeing your thumbs up because I told you my secondary screen is not working pretty
जी
much.
सर,
Huh.
जी सर.
Yes,
Nice.
sir.
Yes, sir.
Okay. So then we have sources by which we measure the data. So we have sources which generate this data. So the sources can be, for example, we can have some observations, we can make some measurements, we can record this data. So these sources, they are basically called as data generating processes. So how is this data generated basically? So there are different data generation process. Let's suppose I'm talking about weather. So by weather I mean, for example, if you keep on track of the temperature that's in Kashmir on daily basis, so you have a measuring equipment. So the generation process basically is nature. So nature is generating some data, and you are recording that data. Okay, why am I talking about this data? Because just keep in your mind that whenever you are training any machine learning algorithm, it requires data. I hope that this data concept of data is clear. What is qualitative data? What is quantitative? What is structured, unstructured? What are the different sources? How do we derive it from observations and measurements? How do we record it? Okay, this is clear. Is it clear now? Let's move to the next section.
Yes, sir.
So we'll see now if you have humongous number of data. For example, right now we just have few files of your data. Let's take an example of YouTube. So YouTube gets daily uploads of like nearly millions of hours of videos. So they have to store it in a structured way because they have to retrieve it, they have to access the data, and maybe they have to modify it sometimes. Some videos are deleted, some videos are added, so they have to keep a lot of track for this data. Okay, if you just talk about this YouTube, so there's a lot of data coming, lot of data is there. So if we take example of our simplest data, maybe we can just store it in our file systems, maybe in operating system. The operating system provides some support for the data. So you have some files stored on your operating system. Let's suppose you have your class information and you have your course information stored in the laptop. So your operating system, maybe if you're using Windows or Linux, it provides some things where you can delete the file, you can update that file, you can retrieve the information. But it is really heavy for operating system. It's really heavy for operating system to do this task, because if we have lot of data and you have to deal with lot of data. For example, let's speak about YouTube as we are doing it now, and we have other companies which deal with other types of data. So for these people, a simple thing cannot work. Like for example, we cannot just take the operating system's file management system and we'll say okay, it will handle all the data. So for that we need databases. So if I talk what is a database, database is wherever the information is stored. So we store this information somewhere. We store the information. So there are some databases. They are called as, maybe we can call them ancient databases, because initially the data was just numerical and text. So when it started, so most of the data was in this format. It was numerical and text. Then we had these videos. Then we had multimedia databases. Okay, so by multimedia I mean there was videos were there, and then we had audio, and we had other stuff like the combination of these things. So this was multimedia data for us. Okay, suddenly something happened. So we had numerical data plus textual data in our, for example, early days. Then we moved on to numerical data. If you now see YouTube, we have a lot of multimedia data in that. We have YouTube and stuff like that. Then there is something called as geo information data. For example, if you speak about NASA has a lot of pictures from extra celestial bodies like sun, moon, and the Milky Way galaxy we have. So they capture information from there and they have to store it somewhere. Okay, so there is data like that as well. So there are a lot of types of databases where we store the data. So basically, what is a database? Database is nothing, just an entity where we store this information, where we store this data. Okay, so then we have to, this data is stored in the database. Just remember this thing. We have to deal with this data now. So we should have a set of software by which we can retrieve the data, we can manipulate the data, then probably update it or do something with it. So for that we have what is called as database management system. Okay, many of you have this undergrad course as DBMS, database management system. So we have data, this is stored in database. Now we have to get access of this data, and we want to do different, I can say, operations. By operations I mean I have to sometimes create data, Sometimes I have to manipulate data, update, revoke, delete, whatever you want to do. So that is done by database management system. So what is a database management system? It basically is a set of softwares which is specialized for this, which is specialized to retrieve or to update or to do any sort of operation on this database. Okay, this data, maybe we could call database plus database management system, we call them a DBS, database systems. Okay, so database plus this database management system, so there is a set of software and the database, we call them database systems. Is this much clear? So what is the meaning of database? So what are the different types of database?
Yes, sir.
Nice. If you have any questions, just stop me there because this is really important. Why is it important? I'll tell you why is it important. It's like used by different types of people. It's not only used by the people who are doing machine learning and stuff. We'll be, I think, looking at that. Who are the people that use this databases? Okay, now we'll see what is the need of databases. Why do we need databases? For example, if we have operating system, if we have these, they're called flat files. So whatever you store in your computer, that's called a flat file. For example, you store a .dox file, which you write in your Word, or you store maybe an Excel file, .xls format. So these files are called flat files. Why do we need this huge database? Okay, so we'll be now tackling why databases. So why do we need to store these things in huge database and what the structure? The first thing is we'll have a structured storage. Structured storage. So what I mean by structured storage is that in a database we stored things into tables for easy access and easy retrieval. Okay, so this basically is stored in tables. We'll see the detailed description of tables as well. What are they called? So I call structure storage basically means systematic arrangement. I'll tell systematic arrangement. So that's the first thing. We can systematically arrange a lot of files. So there will be a arrangement, like good order arrangement, so that access of these files becomes easy, and we have the fast retrieval as well, we have fast updating as well. So this is the first why do we need this, and there should be a structure. And the second thing is relationships. This is really important. Relationships. So what I mean by relationship is, for example, if you have a lot of data files, so this is file 1, so this is file 2, this is file 3, let's suppose over here. So we have this data, it is spread across our system. So what our databases do is we have ability here, capabilities here, so that we can create relationships. For example, maybe there is a column in here which has some relationship with this column. Let me give you some concrete examples. So let's suppose I am running a company. So in that company I have the employee records. Okay, so what I'm doing is I'm making a table of employees. So in there I have employee IDs. Okay, EID, then I have employee name. Okay, after that I have maybe his, what is the salary, and I have some other info as well. Okay, this is what I call as employee table. So then I have other table which I call as dependents. So what I mean by dependents is that, for example, I have a bunch of names written over here. They have, for example, names, then let's suppose age, and let's suppose some other features, some other attributes, we call them. So these two tables are related in a way that this table, the dependents table, it contains the information about the people who are dependent on these employees. So by that, I'm telling that this table contains the information about the family of these employees. So do you see there is a relation between these two? So these dependents are the dependents of the employees. They basically, dependents table has the information about the family members or the people who are dependents on these employees, which we have written over here. Okay, sometimes we need to see, okay, employee ID this, how many dependents are there, and so we have to query this table. So if you have the database, so by the help of database we can create relationships as well. Okay, then there is another thing. So let me give you another concrete example. So told you that there is a structured storage, and then there is a relationships we can create with the data, and then we can retrieve those relationships. Then the other thing we have is that there is no duplication. Mostly there is no duplication. Let me take the example of movies. Let's suppose I have a data set which has movies. So in there, let's suppose there is some movie. So we have a movie name, and let's suppose, and then we have movie ID, movie ID, and let's suppose we have the name of actors in the movie, actors, and the age of actors. Okay, something like this. What if I write like this? For example, if my movie name is A, okay, some movie ID is 1, and let's suppose actor is some ABC, and his age is 30. Let's suppose in the same movie there was another actor. So for that I have to create an another entry for this. So let's suppose I have the same movie A and its movie ID will be 1. Then I have the actor BCD and his age is 40. So let's take another example. Let's suppose in the same movie there is another actor casted XYZ. So his age is 30. So do you see that these things get repeated? As you see that these things get repeated quite often. So that we can have a movie in which there will be 50 actors. So we'll be having 50 times these same values. So what we do in databases, that's called as normalization. Just remember this word, that's called as normalization. So with the help of normalization, we remove these redundancies. So there is normal forms that there is something called as 1NF, first normal form. Then we have second NF, 2NF, 3NF, and BNF. There are a lot of normal forms. So if I talk about norm form, it'll at least take me more than 15 hours to just talk about this normalization concept. So here I'm just giving you the breadcrumbs so that if you want to dive deeper into the databases, you can do that. So you saw that here by using the database, I can create I can do what's called normalization. Normalization is a process by which I create separate tables so as to remove this redundancy. Okay, this is another property what our databases give. I am in the topic why databases, why are we using databases. So in that I told you we are having a structure in the data, we systematically arrange data, then we can also find relationships. Then I told you that we can remove the duplications by using the what's called as normalization. I gave you the example of these movies, so you saw that there is redundancy. Now if I want to remove this redundancy, let me give you an example. I can just create two tables like this. I can create a table of this and table like this. Here I will have movie ID and movie name and movie name. So here I'll have actor and age. Okay, so I'll just fill these columns and these, then I'll create a relationship between these tables and these redundancies will be removed. So now here I'll just have one column A and 1, and then maybe I'll have 3 entries over. So I just remove these redundancies, these two redundancies. Okay, so if you want to delve deeper into this, how to remove these, so that these are the normal forms you have to get. So the best normal form you can get is I think BNF. So in this normal form, every redundancy is removed. That's called dependencies. Basically, dependencies are removed, to use the technical terminology. So the other thing that we can do is, now you know that there is some there are structured storages there. There is a relationship that we can capture. There is no duplication if we use these databases. So does somebody have a question? I think. Does somebody have a question? I cannot see the screen. I don't think you have a question. Let's move forward. Then we'll see again. We saw the structure in the data. We can do this with data. And the thing is, now we need to retrieve this data. Okay. So there is efficient retrieval as well. There is efficient data retrieval. Retrieval. Whatever the spelling is. Okay. So there's this efficient data retrieval. So in that I mean you can query the data. So there is something called as querying. Querying means when you ask something to the database. Okay. So it has really powerful querying language, like we'll read SQL in this databases. So there is this is called structured query language. So we'll use this. So we have fast querying, and there is a technique called as indexing, which we use in this efficient data retrieval. So there is a concept called as indexing. So if you have heard about B plus trees, so these things are used for this indexing concept. So for the faster retrieval of the data basically. So how is this implemented? So you can delve into the deeper details of this in order to get a good hang of it, because I told you this is probably like 1 year long course. I have to sort of shrink it down to just 2-3 lectures so that you get at least some understanding of these databases. So now we have this efficient retrieval data. I told you that there is querying, we have querying language like SQL. Then there is indexing, and indexing is implemented what is called as B and B plus trees in databases, and it makes the retrieval really faster. Okay. Then we have another advantage by using these databases, that is data integrity and security. So for example, let's talk about Facebook, what's called as Meta now. So do you know there was a leak of passwords for Meta, because they had stored all the user passwords in some password server, and it was not properly encrypted. And some people, they just did an attack on that, and they were able to access all the passwords. Okay. So what databases give us? They'll first give you the data integrity and security. By integrity, I mean consistency. So for example, if there are a lot of tables, if there is a lot of detail, and it is spread across the tables. So let's suppose my record is in this table, and my record is also in this table, and my record is also in this table. So in your local computer, if you have these three files, f1, f2, and f3, these three files, and you have a similar record over here, and over here. So let's suppose here there is some information, and here is some information in the table, in the file 3 you have some information. If you update something in file 1, if you update your record in this file 1, so locally it won't update file f2 and f3, irrespective, even it should update it basically. Okay. So there is inconsistency in the operating systems if you just update one. What database take care of? So if you just update one file, so database automatically give you the ability that if they found there is the same data is somewhere else, so it updates it. So there is no inconsistency. Okay. So by inconsistency, I mean if you update it somewhere, so there for example, if you try to read it the next time, or some from some other means, so the other location should also be updated, because the data was similar. So that's where these database become really important. For if you see YouTube, let's suppose, so YouTube has multiple servers. So if you know the architecture of YouTube, so it has multiple servers. If one server is down, other server will be able to provide the service to the users. So let's suppose the video v1, v2, v3 is over all these servers. So if there is some updation on this video v1, so this updation will happen in v2 and v3 as well, in order to maintain this consistency. Okay. So I'll write consistent instead of inconsistency. So databases provide us consistency. So they enforce basically rules of consistency. Okay. Reducing the risk of these errors. So there are very less possibility of errors. Is the concept of consistency clear?
Yes, sir.
Okay. Then they also provide security. Then they also provide security. By security, you know that, for example, home to give access, they do access control. So let's suppose you are the owner of some file. So you just want to give permission to yourself to edit the file, and maybe to your friend, but you do not want to give the permission of edit to some other people. So for that, these databases provide us with the access control, which gives the permission and safeguards your sensitive information from unauthorized access or even some modifications. This is the performance. This is what database gives. So on top of this, databases also give us scalability. By scalability, I mean, for example, if you grow data in volumes, like we just talked about YouTube. So YouTube में कितना सारा डेटा है, तो ये सारा डेटा हैंडल करने के लिए एक स्केलेबल सिस्टम चाहिए. So for that, we need a good system for that. If we have database, so we can scale it up till any extent we want. So for that, we need these databases. Then we have something called as optimizations as well. Okay. So they are optimized for fast retrieval, ensuring that if you have a massive database in which there are thousands, millions of files, and you want to access one file, it should not go through each of the file. It should have faster retrievals as well. So they do optimization, scalability, and optimizations. Okay, we can talk for hours and hours regarding this database. What are the things that these databases provide? I think now you're convinced that we need databases in the real world, so as to do some analysis, or as to do something with the data. And the good thing that I just wanted to remember is there is something called as concurrency. Concurrency, whatever the spelling is, let me concurrent access concurrency. Okay, by concurrency I mean if you want to access a single file, like for example, you have user 1, you have user 2, user 3, and they want to access the same file at the same time. Okay, so multiple access sort of thing. So these databases provide that support. So for example, if you are watching one video on YouTube, so other people also can watch the video at the same time. So that is because the good database they have. So but in operating systems, if you are accessing one file and you try to update it, and if some other guy is remotely accessing your operating system and he tries to open your file, maybe the updations won't happen like that. So this concurrency is provided by these databases. Okay, is it clear?
Yes, sir.
Nice. So we now saw the importance of database, and now I'll just go through some examples where this database I use it, so that you know why to use it and where is the database uses. So I'll say that all of you people, you are interacting with the database on daily basis. For example, you watch YouTube, there you are interacting with a YouTube database. For example, when you log into your Facebook account, when you log into your Snapchat, LinkedIn, whatever you have, so you are basically interacting with the database. So you just query your password and query your email ID, and what happens is it the request goes to the database and it checks for these things in the database. So basically you are always using, in your Android, in your iPhones, you always are interacting with the database on your daily basis. For example, if you go on a certain website, so if you want to download a file, so for that you are going to that server and you are querying the database for a particular file and you are able to download that file. Let's talk about e-commerce websites. For example, management entry, and then you have to, for Amazon is a website, they have to track orders, orders the people, कि किसने कितने ऑर्डर किए दिन में, एंड देन लेट्स सपोज कि उसका ऑर्डर कहाँ पहुँचा, दे हैव टू ट्रैक दिस ऑर्डर्स एज वेल एंड दे हैव टू सी द pricing and stuff like that, and they have to keep all these details. So they are keeping that in a well ordered database, a structured database. Then in social media platforms, if you see, so in social media platforms, which I gave you the example just now. For example, if you are you seeing YouTube, LinkedIn, and stuff like that, so they handle a massive amount of data. So which, because they have user, what's called as user generated content, user generated content. So if you write a post, so it is stored somewhere. So if you see, for example, if you have been on Facebook since last 10 years, so you have posted something 10 years back, so it is stored somewhere. It is basically stored on some server, and there they are using these databases. So even Facebook is now recommending, we would like to show you a memory that you shared 10 years ago. So how is it able to tell it, how is it able to give you that recommendation, is based because there was a data that you have, and they have the data. Even right now, and we rely mostly on these cloud data, because our hard drives crash. If I keep a hard drive, for example, down the line after 10 years, it will crash. So my opinion tells me that the better thing is I should store it in the cloud, so that I get the better access and there is no problem of like loss of data or something like that. Okay, and then the people who are in data analytics, they have to take decision making. So they also are in that, maybe in data analytics. So they also use interact with these databases for these real time applications and things like that. And financial institutions like banks, financial institutions, so they also use these. For example, if they want to check your bank balance, they have that bank balance stored in some server. If you want to see some other, like, is my account credited, is my account debited, so all these things are basically done by databases. Okay, so now we'll see the types of data. We'll now go into the meat. We'll go into now into the meat of this topic. So what basically are database and what the types of databases, or what is SQL, and we'll go into the details of that. If you have some questions, I'll stop here for maybe 10-20 seconds. Okay, I don't think you have a question. Let's go on the types of databases. Types of databases. Am I audible? Am I clearly visible? Because I'm not able to see the second
I'm not
machine.
able to. Yes, sir.
Nice. Okay. So the first thing we have what is called as relational database. Relational database. So we have a relational database. So what is the relational database is that the things, the files that we are stored in here are stored in tables. We call them as relations basically. These tables are called relations. And there is something called as predefined schema. Predefined schema. So in relational database, we have data stored in technically relations. Okay, those relations are actually tables. So naturally, there is a question there. If there is a relational database, there will be no relational database as well. Yes, that is called no SQL. So here examples are MySQL. It's a database, and then we have PostgreSQL, and then we have SQLite and database like that. Okay, so all these databases, they are relational database if you see, and if you also know that the things about Oracle, okay, Oracle, and maybe Microsoft SQL Server, which I just discussed, and there is something called as Visual Fox Pro. So there are most of the times this database is used right now because it has become sort of industry norm now. Most of the people who use this relational database, but there are other types of database that I'll also like to discuss with you. So in nutshell, I'll say relational database. Should I write definitions as well to facilitate the notes, or are you writing it on your own?
सब लिख रहे हैं खुद ही.
Okay, so how many of you are making notes at least? Because these sessions, most of these will be theoretical. I think 1 2 sessions, then we'll go into the coding. Okay, okay. So you're making notes, good. So I don't need to write the things explicitly. So it's good that I don't need to write them because I'm really bad at writing and I don't like writing much. And then my handwriting is more or less like doctors. So it's good that you make your own notes. Then we have something called as NoSQL database. Databases. So in this database type of database, the data is stored basically in some unstructured or maybe in semi-structured form. Okay, it is stored in unstructured, unstructured, or semi-structured form. Semi-structured form. I told you what is a structured data, what is unstructured data. So maybe in this, so there, for example, if you have heard that these became famous recently, I'll say, for example, MongoDB. So people now are using MongoDB for their websites and things to interact, and they have something called as graph database. Neo4 is something, some example. So I personally have used this MongoDB. So now it is sort of taking off, and people now try because it has some other advantages over this relation database as well. So we wouldn't want to go delve into deeper into what these things. I just want to call out the names, so the different types of databases that we have. Then we have something called as in-memory databases. We have something called as in-memory databases. In-memory databases. So here the data is stored in memory directly. For example, in your operating system, we can call it an in-memory database. So data is directly stored in your memory, and then it is giving us the faster access. Okay, and then we have a data warehouse as well. Data warehouse. So in that you have large data. For example, if you have some historical data. If there is a company, let's have, suppose Apple. So Apple has some data from past 30 40 years. So if they have to store it, some historical data, store it somewhere. So they store it in this. That's called as data warehouse. Okay, so they optimize it for querying, and then there are a lot of features like aggregation and analytics, and it has complex querying capabilities as well in this data warehouse. Uh, all in all, most of the time we'll be dealing with this relational database. So here we'll be using SQL. It is the query language which is based on this relational database. So we have nothing to do with this, nor with this, nor any other. So our focus in this course is this relational databases. Okay, so this will be the major focus because most of the times people use this relational databases. Is this clear? Then we have some graph databases as well. Now we'll go to SQL. So what SQL is? Okay, I won't tell you today like what are the I won't write code today, but what the main focus of today's lecture is to give you at least some experience of databases and then see the bigger picture of what SQL can do and what databases are. So this is the target for today's lecture, so that you get at least some understanding of the lectures. Okay, so SQL basically is a relational database. A relational database. So this is what we'll be using most of the times. We'll be using this to query our data, and will write code into this and code into this. Let's delve deeper into this relational database and relational model. So this relational database is built on what is called as relational algebra. Relational algebra. because there was a guy who invented this. His name was E.F. Cod. I don't know. I don't know his spelling. Maybe E.F. Cod is like this. So he invented this in, I think, in 1970s or somewhere around there. Okay, so he was a mathematician by profession. So that's why he used what's called as relational algebra in there. So high objective, that we saw that there was an objective that there should be high degree of data independence. So his objectives were, so why he is creating that objectives were that the first objective was high degree of independence, degree of independence between data. Basically the concept of normalization that we saw, and then it should be consistent, and then should be no redundancies and things like that, and to enable what is called a to enable set oriented set oriented data manipulation language. Okay, there are a lot of objectives. I am just mentioning few of them because this is written in his research paper. So he actually published a research paper based on this. So he called it a relational model of data for large, I think, shared banks or something like that. So he published a research paper on this database, and then it became famous. His name was E.F. Cod. I wrote it somewhere. Yeah. So he wrote a paper on this, and he has mentioned objectives in there, and a lot of things that he mentioned in there. So what is so special about these relational databases on, and what is the relational model? So what are the terminologies that we will be using in this relational in this SQL basically? So there are some concepts and things that we'll be frequently using. The first thing is we'll be using a concept or a terminology, a relation. So I'll just tell you a relation. What is I'll sometimes speak about this is a relation, and this is having say this attribute, this is having this row. So basically a relation is nothing but a table directly. If I talk in blunt terms, this is just a table. So why is it called a relation? Because there is data, and data has, mathematically I can explain why is it called a relation, but I don't think it's needed. So you can just say a relation is a table which contains rows and columns. Okay, it contains rows and columns. So these rows, they basically contain the data about something, and these columns, they contain attributes. We have been seeing this in our pandas library. If we store a data in some pandas data frame, and then we have these rows which have each data point, then we have these columns. So what is this attribute? Attribute basically tells us the relation. Okay, attribute tells us the relation. So I'll tell you, I'll have a table of people like this. So here I have employees and employee IDs. So here are the employee name. So why is it called a relation? Basically because these attributes have some relation within themselves. So I'll say that if we have an employee name, his name is, let's suppose, John. So John's employee ID is 124. Okay, so there is a relation between this 124 and John. The relation is that this 124 is employee ID of John. Okay, that's why it's called a table is called a relation in relational database. Okay, then there is something called as domain. The first terminology that we saw is a relation. Then we saw a terminology of attribute. So attribute is what is described by these columns. They are called attributes. Then we have another terminology of domain. Domain means that what are the values that these attributes accept. So let's suppose this name, it accepts the attribute of names of people. These employees, let's suppose they are some 5-digit numbers. 5-digit numbers. So this is called domain. Okay, we're just seeing what are the terminology of the different terminologies that are used in this relational database. I would like to say the domain is acceptable values. Acceptable values taken by attributes. Okay, is this domain, is this concept of relation, attribute and domain clear? Is it clear?
Sir.
Then we have what is called as tuple. Again, a row in this relation, a row in this table is called a tuple. So I'll write a row in the relation, which we call a table basically, is a tuple. So any row, so if I have a table like this, so any row in this table is called a tuple. This is a tuple. Okay, So then there is a concept of degree. Okay, so degree means the number of attributes. So here we have these columns. So each column is one attribute. So I can write number of attributes, number of attributes in a relation. So in other words, I can just say that number of columns is called the degree. Okay, is it clear? Is the concept of degree, tuple, because they are really basic concepts. I just want to make these terminologies clear, so if I use it somewhere when I'm talking about SQL and things like that, you should not get confused. Okay, oh, what is he speaking? Degree. So is he talking about MBBS degree, or is he talking about some other degree? So degree here means in this relation how many attributes are there, how many columns are there. Then we have what is called as cardinality. Okay, so the cardinality means number of tuples in the relation, that's in the table. I'll just write table in the braces so you know that this table is basically called a relation in this relational model. Okay, this is what are the terms I'll be mostly using. Okay, so we'll be using the term relation. The relation basically means table, and this table contains rows and columns. And what is an attribute? Attribute is basically these columns. What is a domain? What are the acceptable values that are taken by the attributes? They're called domain. That's called domain. Then we have a tuple. By tuple I mean a row in the relation is called a tuple. And then we have degree. Degree basically means the number of attributes that are in the relation, or we can say the number of columns that are in that table. Then we have something called as cardinality. Cardinality means the number of tuples, or I'll say number of rows directly. I'll say number of rows. Okay. Do you see that it resembles set theory? So you have, I think, read about set theory in your plus one, plus two. There is a chapter of sets. So there you have also seen the concept of domain. There you have also seen the concept of cardinality, maybe a degree as well. So have you seen these concepts in sets?
Sir.
So there's a chapter sets, relations, functions, I think in plus one or plus two. So in there, all these concepts there. So I told you E.F. Codd, he was a mathematician. He borrowed all these concepts of mathematics. Okay, and then we'll see that there is a union. So if you have a really good grip over this set theory, if you know this set theory, so it'll be really easy for you to understand these relational databases. So underneath the hood, whatever E.F. Codd used, he proposed a data model which is based on this set theory. Okay. So I hope that these terms are clear for you. Is it clear?
Yes, sir.
Okay. If you have Yes. if you have any questions, you can ask me questions. Otherwise, I'll move forward. Nice. Because I got a complaint from some people that, sir, you are going really fast. Can you just slow down your speed? So I thought of writing. So I thought when I'll be writing, I'll slow down speed a bit. So it is better way of. So is this the better way, or do you just like the way I teach in on those IPython notebooks, or do you like this writing way so you get some time to absorb the material? I need comments from you.
So this one is better.
So this one is better because you get some time at least to absorb. Because I got some, I think, pretty comments, and some people called me and they told me that you have been teaching fast to these people, and even my mom was telling me, "So क्या करना? चुके मैं पढ़ना हमारा scalpel करता." So I thought I'll just use the pen tablet so that you'll understand these things better and get uh, some time to grasp the material. Okay. Now that you know what these terminologies mean, so now we are in a position to go into what is called as SQL. Okay. So SQL's full form is structured query language. Structured query language. Okay. So structured query language, it's a standard programming language which is used to interact with databases. Interact with databases. Okay. So now you have the data stored in some system which we call as databases. So we have to retrieve and we have to manipulate, we have to perform different operations on the data, and basically you have to interact with the data. So you must know a language. So if I have to talk with you, if I have to talk to computer, I must know a language. In order to talk to computers, I should know the language of computers. In order to talk to you people, I should know the language of you guys that you speak and that you understand. So in order to interact with the database, you must know their language. So they have a language what's called a structured query language. Okay, it this language provides a systematic approach. It provides a systematic approach to interact with these databases. Okay, this is really simple and really elegant as well. Sometimes things are simple but they are not that useful, but this is a thing which falls in both categories. So it is really simple to understand, it's really simple to learn, and it is really elegant if you see it. So it allows the users to perform different operations on data, like retrieve the data, insert new data, update the data, delete the data in the databases. So what are some key components in this SQL? Okay, we'll write some key components. What are some key components? Some key components of SQL. Okay, so for example, the first thing that we have in here is called as data definition language. Data definition, DDL. We call it DDL, data definition language. So because the first thing that you have to do, you have to create data. तो डेटा को हमें पहले बनाना है, then only we can manipulate it. Okay, so if you have some data, you have to create the data, you have to sort of have this data in hand in order to do something. So there is a thing called as data definition language. Data definition language, or DDL, data definition language. What's the purpose of this? The purpose is that it defines and manages the database. Okay, it defines and manages database. So this is one component. So here we are talking about there is a machine, for example, the machine has different components. So there are broadly three components, or maybe I'll say four components in here. The first component is data definition language. So here I can say what is the purpose of this. So purpose is that it is used basically to define and manage databases, manage DB. Okay, so what are the operations that you can do? So operations, I'll write operations. What are the operations that you can do with this component? So operations are basically, you can create, if you want to create some files, you can create the files, you can create the data, and then you can alter the data. Maybe, for example, change the names of this data, and then maybe you can drop or delete some, and also dropping of things, like you can drop one table, you can drop some indices, you can drop some views or something like that. So this is the first component. The first component is data definition language. Okay, we are in the components of SQL. So we saw what SQL means. Okay, then we are in the components of SQL. The first component is data definition language, DDL. Then the second component is DML, data manipulation language. So you need to manipulate the data now. Manipulation language, DDL, DML. So DML means data manipulation language. So here what is the purpose and what are the operations? So the purpose and what are the operations? Okay. So the purpose here is that you can manipulate data, you can perform certain operations. For example, here you can manipulate data. That's why it's called manipulation language, because you want to perform certain things on the data, and you want to manipulate in a certain way, and you can do that. For example, if you want to select one table, if you want to select one relation, if you want to select one row, and if you want to insert one row, for example, you have a table and you want to insert one row into that. Sometimes you want to update that row in some other way. If at all you want to delete something. So these are the operations that we do under this data manipulation language, or DML. Then we have something called as data control language. Okay, these are the components. Third component is data control language, data control language, DCL. Okay, again same thing, we'll write its purpose and we'll write the operations that we can do by these components. This is some sort of virtual. I cannot say that if you tell me are they physical components. No, they are not physical components. So they are the broad categorizations. So when we classify something, so it may not be physical. So here we have these components in SQL. So it is the broad categorization. So what are the capabilities of SQL? So we saw there is data definition language, because the first step in anything is we have to create data. The purpose is that you need to define and you need to manage this data, and for that you have this data definition component. Then we have data manipulation language component. So in that you have to manipulate data, the operations, or you need to select data. Sometimes you need to insert and the data point. Sometimes you want to delete the table, or you want to delete some attribute, or maybe some row. By row I mean tuple. By attribute I mean the attribute, the column. And then we have data control language. What it does, the data control language, basically it manages access. So who are the people who are authorized to sort of view this data? Who are the people who are authorized to edit a file? They can do some particular things. So it grants permission for the people. For example, if you are a database administrator, so you may have access to everything. But if you are running a company, so to certain data you do not give access to certain people. So in order to manage that control, you will use this data control language component of the SQL. Okay, what are the operations? Granting operations. What are the operations? Are granting some access or revoking some access. Okay, right now I'm also being sort of this data control language. When I'm uploading the notes, I have given access to only set of the people who are registered with us. Then other people we are not giving the access to the notes. Okay, so we are somehow using this data control language analogy of that. Okay, then the last component of this SQL is this transaction control language. Okay, transaction control language. Transaction control language. TCL. Again, there are operations, and then there's a purpose. There is purpose, and there is operation. Okay. So what's the purpose of this? It manages transactions. So I'll tell you what is a transaction. It manages transactions. So for example, if you are using the bank's database management system, so your bank balance is for, let's suppose, rupees. Uh, let's suppose we are poor people, so we'll have just 150 rupees in our bank account. So if I deduct, or if I just transact, if I take 50 rupees out of my bank account, so what will happen is, so there will be a step of processes. So the first thing is it should update my throughout this, because I deducted this balance, so it should be the 100 balance should be shown there. So there's a step. First step is that whether the amount was really given to, for example, me, I deducted it, and then I'll say this transaction is complete if the balance that I deducted and the balance that I have right now, it's equal to the initial balance. Or just giving another example, if I want to transfer some 50 rupees to another account, so let's suppose this is, let's suppose, Rian, and this is let's suppose Mahvish. These are two people who are transacting something from their accounts. So Rian, let's suppose, have 500 rupees of bank balance, and maybe Mahvish suppose has 1000 rupees in her bank balance, because girls really are richer than boys. So, and Rian owes some money to Mahvish. That's usually the case, because most of the times where these girls are rich and boys have to give them the money. So let's suppose we have Rian has to give 100 rupees to Mahvish. So here, whenever Rian makes a transaction, so the transaction should happen like this. So first, the amount should get deducted from here. So the remaining balance should be 400. So now the 100 will be transferred to Mav's balance, and a second thing should happen, that this balance should get updated to 1100. So you saw that there is a step of process involved in this. So for example, what will happen is, if Rian sent the money and in between the connection was dropped, okay, so the Mavish's balance is again 1000 rupees, but the Rian's money was deducted. So we call what is called as rollback. So you might have even seen the transactions. They call you that in the 3 days your money will be refunded, because in 3 days they again check for the completion of these transactions. So whatever transactions are not completed, they'll roll back it. So by rollback I mean, so they'll again refund you the money because the transaction was not complete, because it does not tally with each other. So here the net balance initially was 1000 plus 500. It was 1500 net balance of both the accounts. So, but after the transaction, if the transaction is over, so it will be, after transaction will be 1500. But if the transaction happen interrupted in between, so what will happen is, So now Rian has 400 balance, but the Mahavish still had only 1000 rupees in the account. So the net balance after the transaction was only 1400. So there is some discrepancy. There is some inconsistency. So what will happen is we'll roll back this. We'll roll back the transaction. Okay. Or if this is the case that before transaction and after transaction the balance is 1500, so we'll what is called as commit the transaction. Okay. So this is what I mean by transaction control language. So this SQL provides the transaction control language because it manages these transactions. If the transaction was happened successfully, or do I need to roll back this? Okay. So there are something called as commits. Operations are like commit. Operations are rollback. Operations are save point. If you want to save something temporarily, and you want to transact it later, is the concept of transaction control language clear?
Yes, sir.
Yes, sir.
Mavish, now you are rich. Now you owe something to Ria. Okay. So this is how these things work. So I don't want to go into the commands directly. What are the commands in there? So this SQL is not a general purpose language. Just remember that, ingrain this in your brain. So this SQL, oh, something happened on the screen. I have this OBS studio, it sometimes creates some problems. Okay, so this SQL, what I'm saying is SQL is not a general purpose language. This is not a general purpose language. Purpose language. So what is the meaning of general purpose? By general purpose, I mean, for example, Python is a general purpose language. C and C++, Java, they are general purpose languages. So if you remember my first session on Python, so I told you what is the difference between a general purpose and a specific purpose or a targeted language. General purpose means you can do a lot of tasks. You can do a different category of tasks. For example, with Python, you can create websites. With Python, you can do data analysis. With Python, you can create machine learning models. With Python, you can create web applications. You can create applications for your own personal computer and stuff like that. So Python is sort of a general purpose language because it does generic tasks. But this SQL, it is a specific purpose language. There is only one purpose. It will interact with the databases. You cannot make a website. You cannot make graphical user interfaces with this. So it is not a general purpose language. We can say it's a targeted language, or it is a specific purpose language. So it is not a general purpose language. That's the first thing I want to tell you about SQL. The other thing is that SQL is what is called as declarative language. SQL is declarative. Declarative language. What the spelling is a declarative language. There are some languages called procedural languages. Procedural languages. Okay. So what's the meaning of this procedural language and what is the meaning of this declarative language? Let's go a little bit in depth and see what are these things. So in procedural language, if you need to do something, you have to give a stepwise procedure to do that. For example, if I have a table and the table contains the records of the people that are studying here. So let's suppose this table contains students A, B, C, D, E, F, and it contains marks, their roll numbers, maybe their highest degree, and some marks are like 10, 20, 15, 30, 12. Maybe the marks are out of 30. So what I want to see is, if I want to query this and I want to tell, give me the list of students who have marks greater than 15. So this is my query. So in the procedural language, I need to give a stepwise procedure. So what I'll do is I'll write a for loop and iterate over all these people. I'll write a for example, I'll take a list of these students, I'll take a list of their marks, and I'll iterate over the whole list and see where are these marks greater than 15 and return those people. So here I am giving a stepwise procedure. I am giving step by step procedure. So I'm giving step by step procedure in order to achieve certain tasks. So okay, so we call it specific certain. I'm saying that we can say that we can specify actions. Each action is specified, and there's a certain sequence in which I call it, and then I'll be able to get some data out of it. This is what is called as procedural language. C/C++, Java, Python, all of these languages, they are procedural languages, because in order to achieve any task you have to give a stepwise procedure over there. Then we have declarative statements. Declarative statements are, we declare something. For example, I'll say I ate the food. I ate the food is a declarative statement because I do not tell you the process of eating food. So similarly, this SQL is a declarative statement. You will not write these for loops, conditionals, if else, and things like that. For example, in this, if you have to say out of this table, give me the people who have greater than 15 marks. So you can just say select, for example, select uh, from table. Let's suppose I'll just write in plain term because you don't know the syntax right now of SQL, so I don't want to overwhelm you with syntax. So I'll just write select from this table, and I'll just write the attribute where the marks is greater than 15. So here I have not given the explicit procedure. I've just declared something. Give me this. That's what makes the SQL simple. This is the property that makes SQL simple because you are just declaring something and you are getting out of it. Under the hood, you don't know what's happening, how is it getting for you. I don't care about that. Okay, so that's why this programming language is so simple. Even I think like many of the people who are in HR departments and the companies, they do use this SQL for the faster access. And it's really, if you just give it, I'll say 4 to 5 days, you'll be easily able to master this language because this language is so limited and it is based on the relational algebra. Okay, so is the difference of declarative language and procedural language clear?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So now I want to tell you that now you saw that it's a declarative language. So there is a natural question. So computer still needs to sort of understand how to convert this from the computer command. So there is an execution cycle, what I call there is an execution cycle. There is an execution cycle of SQL queries. Naturally, if something is declarative language, the thing is that if I declare something, but underneath the hood there will be something that will be going on in order to give me the results. Okay, so I want to show you what is the execution cycle of SQL query. If you write a query, for example, select from this table the data for the marks greater than 15 or something like that. So this thing is basically changed into procedural language down the line. Under the hood it is changed. So how is it changed? I want to give you the steps of that so that you know what is happening underneath the hood for these declarative languages. The first step, it'll be a just simplified overview. I'm just giving a remark here. It will be a simplified overview. Simplified overview. So why am I telling it upfront? Because I have friends who work in databases. They'll be really mad at me at this point because they'll be sir, you are just degrading our subject because they are doing research on this subject since 3 4 years, and it's an active area of research. I know people who are just doing research over this execution cycle of this SQL query, and they spend their 3 4 years only on this. So I do not want to sort of put them down, and I make to make it just simple. I am telling you that I am giving a simplistic overview. Okay, so what are the steps involved in there? I'll just give it maybe brief 5 to 10 minutes overview of this. And to my friends who will be watching this session, I don't want to degrade the database scientist. Okay, the first step is parsing. So whenever you write a query, the first step that this SQL does is there is something called as a parser. This involves basically breaking down. It involves breaking down of the statement. Breaking down of the statement of the query basically. I'll tell it a statement. So whatever we said select something from the table which has these. So the first thing is it will break down it into components. It will break down the statement into components. Into components. So when it will break down these components, it will check it for the syntax mistakes. If there is some syntactical mistake, for example, if I write select and I misspelled it, I wrote SELT only. So there is a syntactic error. So it will detect in the parsing stage, this syntax error will be detected. So it will take hold of the query and break down it in the state. That's sometimes called as tokenization as well, if you know. So it will tokenize it. Okay, so by tokenization I mean that it will break down this SQL query and make it into separate components, and to check these syntax it will see if it adheres to all the rules, if it follows all the rules of the language. Then what will happen is it will go into the compilation phase. There is compilation now. So when everything is good, and I told you this compilation itself, it's not just a topic, it's a subject in itself. This compiler design is its subject itself. There are different stages. I think you might know Jeffrey Ullman. I just attended some talk. He came to visit us and we visited his talk. So he has written a book on compilers. It's called Dragon Book. So on this compiler design, it's a huge topic. This is not just a, I'm sorry, I'm saying this is a topic. This basically in itself is a huge subject. Okay, so this compilation After this parsing, now the compilation will happen. What will compiler do is they'll generate the code of procedural language, generate the code, because now that this parsing happened, okay, so we'll now generate this code in either in C++ or in Java, or maybe in Python or something like that, because we had this procedural language. So I know that a computer won't understand the declarative statement. I have to give it a stepwise procedure basically. But what we have done is first we'll parse that statement. When the parsing is done, we'll break down the statement, check for the syntax errors. If there is no syntax error, parsing happened, then we'll go into the compilation phase. In the compilation phase, I'll convert this declarative statement into the procedural code. Generate code. I'll say generate the procedural code. Okay, so this will be generated, and this code depends on the basically who is implementing it. If they like C, so they'll generate that code into C or C++, or maybe in Java. I have also seen people doing it in Java, so they also convert this parsing after this parsing stage, and they use the Java directly. Then there is an important phase that's called as optimization. There is a phase of called as optimization. Just to interrupt in between, am I boring you with this stuff, or should I skip this, or should I continue?
So continue, sir.
So how many people are telling me to continue with this stuff? Because this is sort of the stuff which will give you the broader perspective of these languages.
Continue, sir.
Okay. Because I don't want to overwhelm you with the information, because that's not needed. But I think that this information needed so that you get the broader overview of these things. Okay. Then we have something called as optimization. After successful parsing and after successful compilation, what will happen is this DBMS. It's called, there is a query optimizer. The DBMS, database management system software, it has what is called as query optimizer. So this query optimizer will take charge now. So this will take the code and it will analyze the query, and it will generate the multiple execution paths. It will generate multiple execution paths. So I think this lecture will be watched by the people who are with me. So I'll just call out a name, Sneha. She is an expert on these databases. So she'll watch probably this lecture. If I'm wrong at some point, you can just comment it down, because you are an expert in this field. So with the help of her, I sort of created some notes for this database, and she shared some material with me. So we have this multiple execution paths. So for example, now there can be a path like this. So there are multiple paths by which you can achieve the same task. So in this optimization thing, this query optimizer, what it takes the most optimized path. Okay, so let's suppose there are 3-4 paths available, which will basically give you the same result. The same result will be obtained. But what this query optimizer does is it will take the best path among all of these. It will take the best path. It will just check which are these best paths, and it will give you that path. Okay, what it does is after successfully parsing, the DBMS query optimizer, it takes charge. So it analyzes the query and generates multiple execution plans. Okay, considering the different strategies to retrieve that data efficiently. So for example, there are different factors involved called as indexes, stats, join. I won't go into that. So there are different algorithms that are involved in this. So it will just pick out and give the execution plan. So then we have this when it gives these multiple paths. So after that we have a step called as execution plan generation. Execution plan generation. Execution plan generation. So now this optimizer, query optimizer, what it gave multiple paths, and which give the same results. Now this execution plan generator will give the best path out of these. Okay, it will choose the best path, or choose the best path, the best plan, let's suppose. By best plan means that it should optimize all the things. It should be really faster than other paths. So it will be done in this phase, execution plan path. Then the last step comes, that's execution. Then we have the step of execution. Now the things will be executed. Okay, and then we have result retrieval or something. Like till this we got the execution done. My mouse is not working again. Okay, so after execution there will be what's called as result generation, and then there will be transmission of result for you. So there will be then, so here we will execute the commands that were the plan that was chosen by this execution plan generation stage. Then we will have this let's call it data transmission or something. Let's result generation. So result generation. So we'll have this result generation, or maybe we'll also have to transmit this result onto the user. We'll transmit the result as well. So as it's a declarative language, so this is a high level overview how a declarative language works. So there is a execution cycle of SQL, which I just told you. There is a parsing, then there is a compilation, and in the parsing itself there are multiple states. In the compilation itself there are multiple states. In the optimization, it's a huge topic. There are a hell lot of algorithms, and then to take these and analyze all these paths. So there are again a lot of tasks involved. Then execution is somewhat simple. It's not simple. It's somewhat simple. Then we generate the result and we transmit this result to the user who is basically querying the language. So did you like at least the path it follows? How do we convert it, that declarative statement and all of these things, and then give the result back to the user?
Yes, sir.
Okay. I think I'm getting some calls from somebody. Sorry for interruption. Okay. Now we'll move on to our next. Now you understand that the all of these things, that how this execution is being execution cycle happens, what is being done. So now I told you all the things which all the terminologies that are used in this relational database. So I told you about a relation, basically a table, then an attribute, a column, basically a tuple, a row, and then we also spoke something about range, something about domain. Then we saw something about cardinality and degree. All of these terminology will use it now. So if we have a table now, so all the things that we'll be storing in the relational database will be in form of a table, in form of a relation. So there is an important concept that I want to discuss, is the concept of keys. Okay, so we have a table like this. Let's suppose we have this employee table. So employee has employee ID. They have something called a social security number. So we have name. So we have address, and let's suppose we have age as well. I'll just call out the names. Tell me what is this table called, so that to reiterate the terminologies. So what is this table called? Any one of you? Maybe Rian. What is this table called?
Relation.
A relation. So what are these columns called? Umar, are you there?
Attribute.
Attributes. Nice.
Attribute.
Attributes. So what is a row called? If I talk about a row, what is a row called?
Tuple.
A tuple. Nice. Okay. So if here we take numerical values, so what is the, if we have these values, so what is it called? The acceptable values, what are they called? Acceptable values are called
Domain.
domain. So what is the meaning of cardinality? I'll just like reverse the question now. What is the meaning of cardinality? The
Number of
number
rows.
of tuples, basically number of rows. Okay, number of tuples. So what is the meaning of degree? Number of attributes. Number of attributes. Okay, I think that the terminology is clear now. So now I'll go on the important concept, what are called as keys. Okay. So what is a key basically? So for example, now we have these attributes. Out of these attributes, we want to uniquely, not even uniquely, we want to extract, let's suppose, a row out of this, or some data. So we have to basically give keys. So keys, they are the requirements of this relational database. I'll first say that they are the requirements of the database because they identify these tuples. Identify the tuples. I will now use I will not now use rows and these columns. I'll use tuples, attributes, degree, cardinality, and things like that. That's why I just rehearsed these things so that you know these things. So keys, they identify these tuples. So if I have to get this one row, so there is a keys by the help of which I can get that. Okay. So in short, keys are something that we use to extract the tuples, extract the information out of these relations. There are a lot of types of keys. Okay. The first type of key is called as primary key. Let's start with primary keys. I see I have written some things over here. Let's start with a candidate key. So there are a lot of types of keys. I'll start with candidate keys so that it becomes easy for you to understand what's the meaning of primary key and secondary keys. So I'll first see what is a candidate key. So what do we in the normal day-to-day life? What we mean by keys? So keys are there to open some locks. Okay. So key basically a key is there to open a specific lock. Consider these tuples as locks, and you have to open them basically uniquely. So here we consider that these keys are sort of things that they'll open only one lock. So key is not a thing that will open two three locks. So that's the normal things that we use keys in our day-to-day life. We call this is a key because this there is a match to this. The key has a lock. Key does not have multiple lock. A lock does not have multiple keys. Or it may have these duplicate keys, but it does not have different multiple keys. The first thing a candidate key, it's a set of attributes set of attributes that uniquely identifies a column identifies a tuple. Okay. So if we have a set of keys, for example, if I here want to uniquely identify this row, maybe for example, let's suppose name can get repeated. So I can have name like John, I can have like name like let's suppose Jahangir, then somebody's name is again John, but he's a different person. So you can see that by using only name, I cannot uniquely identify one record. Sometimes this tuple is called a record as well. This tuple is called a record, one record. So in order to uniquely identify a record, this attribute is not env. So there we can use more than one attribute. For example, with use by using name and the address. Okay, maybe I can uniquely identify a record, but this is not also enough because sometimes in the same location, two persons with the same name can be there. Let's suppose in my for example colony there are people who are named Bashir Ahmad Lone and Bashir Ahmad Lone, so they are living in the same colony. So the name and the address is not enough to uniquely identify these people. So maybe I'll again use, for example, their age, and yeah, they have different age. So what I'm saying, the candidate key is basically a set of attributes, okay, a set of attributes which are able to uniquely identify each record, each tuple. I'll say each record or each tuple in a relation. In a relation. Is this clear? So here, for example, maybe by using employer ID and social security number, I'll be able to uniquely identify a record. Is it clear? Is the concept of candidate keys clear?
Yes, sir.
Okay.
Yes, sir.
So because when you'll be using SQL and you have to uniquely identify records, so for that you must know what are the candidate keys in there. So this is the concept of candidate keys. Now we'll move on to the primary key. Okay. Sometimes my mouse stops working and I have to switch it on and switch it off again. Okay, then we have the second type of key which is called as primary key. Primary key. Okay, the primary key basically is selected out of these candidate keys. Okay, it is basically chosen out of these candidate keys. But what is the problem with this? Sometimes a candidate, there can be a bunch of keys, and some things will candidate keys have may have null values. But here for primary key, null values are not allowed. Okay, so if I write a definition first, so what is a candidate? What is a primary key? It is selected out of these candidate keys, out of candidate keys. Because sometimes I can have different sets of things which can uniquely identify a row. Let's suppose I can have this EID and SSN. They'll be able to uniquely identify a row. I can have some combination of, let's suppose, SSN and address, SSN and plus address. They can also identify uniquely a row in the table or a tuple or a record in the relation. So there can be multiple candidate keys. Okay, there can be multiple candidate keys. Do you agree with this? There can be multiple candidate keys.
Yes, sir.
Yes,
because,
sir.
because I can just take a subset of things and I can uniquely identify one record. But for that, if I want to select a primary key, what I'll do is I'll select like most of the people, what they do, they'll select the least subset, the less number of attributes. They select least number of attributes. Like mostly this is done. They'll select the least number of attributes out of this candidate key and they'll make it a primary key. So primary key, it is again uniquely identifies a row, but it is selected out of these candidate keys. So when it is selected out of these candidate keys, so it mostly what will happen is we'll select the least number of attributes in that primary key. For example, here I can say that this employee ID is enough to just identify these rows uniquely if I have just only one attribute. Sometimes if I have 3 4 attributes to uniquely identify, I'll just take the key with the 3 attributes only. So mostly what we do is with a primary key we'll take the least number of attributes that we'll use as a primary key. Okay. So there are something called as super keys as well. Third is super key. So super keys. So now you have these candidate keys and you take a set of attributes or something like. In super key, what you will do is you will again do the similar thing if you want to uniquely identify something. So it can contain. So here most of the times these candidate keys also the super keys comes out of these candidate keys. So what will happen is, for example, if I have a candidate key of, let's suppose, SSN number and EID, so this thing is enough to sort of uniquely identify tuple. If I add just one more attribute, name, so do you agree that still we'll be able to identify that tuple uniquely? Do you agree with that? So because I know that I have these two attributes which are enough to take the which are just enough to do that uniquely identification of one tuple or one row, but I'll just add one more attribute in that. So it will not change the fact that I cannot identify the row now uniquely, because these two things were enough. If I added one more attribute with this, okay, I'll still be able to uniquely identify it. But I'm just adding one more column. You might have heard about superset. So for example, if something is, we have a set A. So if we have a set B, and this B contains all the elements which A has. Okay, if A is a set and B contains all the elements which this A has and some more elements, we call this B as a superset. So how many of you remember the superset concept? Okay, what is a subset? Can you give me a definition of what is a subset? Because I told you this, all the thing, this SQL, it's based on set theory, relational algebra, what we call them. So I'm saying if I have a set, let's suppose A, let's give me a concrete example. I have 1, 2, 3. Then I have a set B. So it is 1, 2, 3, 4, 5, 6. Let's suppose till 10. Do you see that A is a subset of B? Do you see this?
Yes,
Yes,
sir.
sir.
Do you see that I can write B is a superset of A?
Yes, sir.
So by that I mean that B contains all the elements which which are there in A and some more elements. So what I'm saying is a super key is a key in which we have some attributes. For example, SSN is an attribute, EID is an attribute. These, let's suppose these two attributes were enough to uniquely identify a tuple, to uniquely identify a record in the relation. But what I did is I just added one more attribute, the attribute of name in here. So now it is a superset of the primary key, it's a superset of candidate keys. So in candidate keys, what we do is we would not take more elements, we would not take more attributes. We'll take only enough attributes which are able to uniquely identify a tuple. But in the super key, we'll add some other attributes as well. So it becomes a superset. Okay. So here SSN and EID is also there and other attributes is also there. That's why it's called a super key. So here we are only taking those elements. If we just remove one element out of the candidate, for example, I have a candidate key in which columns are C1, C2 and C3. I mean that I must have these three columns in order to uniquely identify a tuple. If I remove the C3, it no longer remains a candidate key, because with the help of C1 and C2, I cannot uniquely identify a tuple. So if I have another column, for example, by the help of C1, C4, C8 and C9, okay, what I'll do is I can uniquely identify a tuple by using these four columns. So this is the concept of candidate keys. Out of these candidate keys, I'll take this primary key because this has the least number of attributes. This is my primary key now. So what is a super key is, so I have attributes. I know that by the help of C1, C2 and C3, I am able to uniquely identify a tuple. I'll just add C4 again. So this now becomes a super key. Is the concept of super keys, candidate keys and the primary key clear? Is it clear?
Yes, sir.
Okay. So what I'm saying is, then there is a concept what's called as candidate keys. Okay, there are called candidate keys and then there are alternate keys. So as I told you that out of these candidate, let's suppose we have C1, C2 and C3. This is one set of attributes which are able to identify a tuple uniquely. Then I have, let's suppose, C1, C4, C8, C9. Then I have, let's suppose, C1, C8, C and 12 and C14, C16. This is another candidate key. So this is my these are my candidate keys. Candidate keys. By candidate keys, I mean that I can select these keys and they'll be able to uniquely identify a tuple, a record in the table. So out of this, I will take this least amount of attributes. I'll call it a primary key. Okay, this is a primary key. So whatever is left out of these are called alternate keys. Is the concept of alternate keys clear? Because I gave you the example, so it should be pretty clear by now. So is the example of alternate keys clear? Why are they called alternate keys? Because they are sort of alternate keys by which I can uniquely identify these tuples. I selected one primary key, but I did not select other keys. So what was not selected as the primary key, I can also select this as primary key. I can select this as primary key, but I told you that norm is will select the key with the least attributes because if the key becomes less than. But you can also, by all means, select this key as a primary key. There is nothing that stops you to take this key as a primary key. But you can only choose one primary key. There cannot be multiple primary keys. There can be only one primary key. Whatever is left out of these candidate keys when you selected the primary key, they are called as alternate keys. Is the concept of alternate keys clear?
Sir.
Okay. Then we have something called as foreign keys. Okay, then we have foreign keys. I'll just write the spelling FREIGN keys. So these are the foreign keys. So what is for example, if I have a table 1, table 2, I mean I have these relations, I have this data. So let's suppose that there is an employee ID in here and there is an employee ID in here, let's suppose. So but this table contains a record of, let's suppose, age of people, and here we have names and address. So EID, so then we have name, then we have address. So here we have EID and then we have age. So we'll have IDs as 1, 2, 3, 4, something like this. Then we'll have age as 50, 51, 30, 32, something like this. Then EID will be again 1, 2, 3, 4, and so on. The names will be, let's say, A, Y, W, X, something like this. Then we have address will be street number 11, street number 14, or things like this. Now I can use this EID, I can use this employee ID to also build a relation with this table. Okay. Okay, a foreign key basically is a set of attributes or set of columns, I can say, that establish a relation between two tables. So here I can say that this EID I can use, let's suppose here I had EID again. So I can use this column to build a relation because I can say with this EID number 1, the age is 50. So I'll just build a relation between these two tables by the help of a set of columns or by the help of some attributes. So this is what is called as a foreign key. Why is it called a foreign key? Because that key is in some other table. So from the names it is clear. Candidate means, for example, when there are people who are going for elections, we call them candidates. Candidate means there is a potential that one of them will become, let's suppose, a leader. So they are called candidates. Here the keys again. All the keys have potential to become leaders. Leader basically is a primary key. If somebody is made a primary key, so then afterwards we have what we decided to call them as super keys. So if we add something on top of these candidate keys, we'll call them super keys. And the alternate keys were whatever is chosen out of these candidate keys as a primary key, and rest are left as they are. So these are called as alternate keys. Then we have foreign keys. Foreign keys are the set of columns, set of attributes which will sort of make a relation with the other table. That's why it's called foreign keys, because they belong to some other table and they create a relation with some other table. Is the concept of foreign keys clear?
Sir.
I think like these are the types of keys. There can be a lot more. I don't want to discuss. I think these are more than enough for our SQL discussion, because when we'll be writing code, so we'll be setting a primary key for one table. We'll be setting this is the foreign key for that table. This is the foreign key for that data. So when we'll be creating this database. So I also want to do one thing. I also want to show you the relationships. So there is a concept of relationships. So relationships between these tables. So there can be a one-to-one relationship. There are different types of relation. There can be one-to-one relation. One-to-one relationship. So what's the meaning of one-to-one relationship? For example, if there is a record, and for each record, for example, if there was an EID, okay, for each EID there was a one-to-one relationship. EID and it has name. So for each EID, we had a name corresponding to it. So it has a one-to-one relationship. So you can see that with this EID, for example, 21, there was an employee named John. If we had an EID of 34, there was an employee named, let's suppose, Zubair. So you can see that here we have one-to-one relationship with these records each other. So here each record in the table is related to one record, maybe in the same table or in the other table, and vice versa. So let's suppose there is some other table age. So here this EID we will relate it to only one record of this other table. So here this is table 1 and this is table 2. Okay, one-to-one relationship means basically if we have a column in let's suppose relation, and we have another column in another relation, and they are related in a way that they have this one-to-one correspondence. Okay, sometimes it's called one-to-one mapping. That's why I told you this is based on set theory. So you might have heard about there are one-to-one functions, onto functions, bijective functions are there. So same thing is with here. So we have relationships in which one attribute has some relation with other table, and each there is a one-to-one correspondence. Each attribute has only one thing to sort of address in here. So they have relationships, one-to-one relationships. Then we have one-to-many relationships. One-to-many. Okay, so how can I describe physically what is a one-to-one relation? So for example, if I have a list of companies and I have a list of employees, so one employee has a one-to-one relation with the company's table, because I'll be only working with one company at a time, because if I work for multiple companies, maybe other companies will fire me. So this is a one-to-one relation. I have one-to-one relation with company set of companies, so I'll be just working with one company at a time. So then there are one-to-many relations. One-to-many relation is that if there is an attribute, if there is a column, so if one value has sort of, I can say, multiple corresponding entries in another table. Okay, that's called one to many. So I'll tell a physical example. Let's suppose we have an employee table, we have an employee table, and we have a projects table. So you know that one employee can work for multiple projects. Okay, so there can be projects ABC. Let's suppose the employee's name is Jahangir. So Jahangir at the same time can work for multiple projects. So you saw that this Jahangir has a one to many relationship with this projects table, or this project's relation. So is the concept of one to many relation clear? One to one means
Yes,
Yes,
yes.
that,
sir.
for example, I am an employee and I can just work for one company. But within the company, if there are projects happening, so I can work for multiple projects at the same time. So I have one to many relationship with the projects table. So then there are many to many, many to many. So many to many basically means, for example, for each project we can have many employees as well. So many to many here means, this is project 1, project 2, and project 3. So initially this was person 1. So person 1, let's suppose we'll call it a human 1. So human 1 works for project 1, but you know that for the same project other people can also work. So there is a guy who works for same project. There is a human 3, human 18, human 19, which is working for the same project. Okay, so here we have one to many relations, because for one employee can work for many projects at the same time. For a single project many employees can be working. Okay, so this is many to many relationships. I hope that one to one relation and the concept of one to many relation and many to many relations is clear. Is it clear?
Yes.
Okay,
Yes, sir.
so this
Yes,
sort
sir.
of sums up our discussion on the basics of these relational databases, and in the next session we'll be dwelling on the coding aspect of this SQL. Coding aspect. So how to code these things. So we'll be working with the data. So I think I have selected a data set of IMDb data set. So do you know what this IMDb is? I think you should know it. Many of you watch Netflix.
That's the rating of movies, sir.
It's a data set of movies where people rate movies. Okay, so we'll be working with this data set and understand this SQL language. I hope that everything that I taught about the basics of this database and the relational algebra was at least some sort of clear. And if you need to watch this lecture again, you can watch it. So I'll just stop. If you do not have questions, I'll stop recording. Otherwise, I'll just wait for 30 more seconds to take your questions if you have any. So I think you do not have questions. I'll stop recording.